Greetings, ladies, gentlemen, and bots that comment suspicious links with random timestamps. I'm Atticus, and I welcome you to the first and possibly only episode of what I am calling ARASNECA, or Atticus rants about stuff nobody else cares about. Actually, I retract my previous statement. I do not welcome all the bots that keep commenting suspicious links with random timestamps on them. Please stop. No one is falling for it. I have had you all
blocked and reported.
Anyways, I digress. I have a lot of questions. I went to a table just to do this. So recently, I've been thinking about time and Einstein's theory of relativity. You see, I've been reading a science fiction book where characters can live to be thousands of years old by using near light speed travel. For example, for a flight that would take something like 20 years in Earth time, the passengers would only experience something like 2 weeks. And since science fiction books are known for being the pinnacle, the absolute top way to get the most reliable and accurate science that's out there, I pondered the following question. How do you define time in a world with interplanetary near-light speed travel? Of course, before I made a whole video on this, I did a little more research than just basing it all off of a science fiction novel. I went to my best friend Wikipedia, and they gave me all the information I needed. Now, some of you might be going, no, not Wikipedia! And while I recognize that Wikipedia has some inherent problems that make it maybe not the most reliable source of information, Wikipedia can help point you to more reliable sources. And frankly, saying that Wikipedia as a whole is a bad way to learn things is an insult to all of the contributors who put hard work into researching, writing, and editing all of these different articles. But I might make a video on that later. Before I get too far into the science and relativity junk, to be clear, if it wasn't already obvious, I am not an expert in any way on any of this information. I will always try to provide the most reliable information possible, but please keep in mind that I am just a high schooler making YouTube videos as a hobby in his room, so I will mess up sometimes. Just don't go expecting like TED Talk levels of insightfulness and accuracy. It's just a hopefully entertaining and somewhat educational YouTube video. Although, I did have my mom look over this video before I made it, and while she isn't a scientist, I'd say she's a pretty smart person, and she said it makes sense, so that probably means it's good. I don't know. First off, the specific part of Einstein's theory of relativity that I'm referring to is called time dilation. This, according to Wikipedia, is, quote, the difference in the elapsed time as measured by two clocks. It is either due to a relative velocity between them, special relativistic kinetic time dilation, or to a difference in gravitational potential between their locations, general relativistic gravitational time dilation. When unspecified, time dilation usually refers to the effect due to velocity. The basic effect is, the faster an object moves, the slower time moves for it. According to the American Museum of Natural History, if you sent someone off in a spaceship for 5 years at 99% the speed of light, around 36 years will pass for everybody who's on Earth. If you want to calculate how velocity can affect time, you can do so using this simple equation. Or alternatively, you can use this calculator that I found online that I haven't verified the accuracy of, but it seems to work well enough. This makes me think about a few questions, including the one I mentioned earlier. When those astronauts step back on Earth, how old are they? Are they living in a different time, or do they jump forward to Earth? Do they really count as on Earth time even when they're in the ship, meaning that they're straight up time travel? That wouldn't accurately reflect the amount of time. Is age based off of Earth time past? What will be synchronous? So basically, I have a lot of questions. As I see it, there are 3 ways to view time. The first is relative time. Time should be based off of the amount of time an object has experienced, so the astronauts would be 5 years older. The second is reference time. Time is a constant forward motion and should be kept that way so that it can be used as a universal reference. So the astronauts may have only aged 5 years, but they are still 36 years older. There's also a third way of viewing time that doesn't have to do as much with space travel itself, but has more to do with planets. In fact, it doesn't even answer the how much older the astronauts are question. I'll call it astronomical time. In astronomical time, each planet has its own time system. It wouldn't make sense to keep 24-hour days and 365-day years on every planet because that's connected to our planet's rotation and its revolution around the sun. In astronomical time, each planet adjusts its time unit lengths to have to do with its own revolution around its nearest star and its rotation on its axis. And I'm sure there are more ways to interpret time and more nuances than I've mentioned, but for simplicity and time's sake, I'm just mentioning these 3. And trust me, you really don't want me here all day. You really don't. You want me to be gone. Now, astronomical time, as I see it, is simply a necessity. It's kind of like time zones. The clock may display a different time, but that doesn't mean you actually jumped forward an hour in time. The only reason I even brought up astronomical time is because I think it brings up an important consideration when you have intergalactic travel. You'll need to have some kind of universal time that people on every single planet can use so that things can happen cross planets synchronously. Relative time reflects best on the actual experience of the person. It more accurately shows how much they've aged, how fast they've been able to do things. That's probably required to do some sciencey stuff, I don't know. And also, it's based off of Einstein's theory of relativity, so Einstein probably would have approved as well. On the other hand, reference time is better for simplicity and scheduling. Since time units are just human inventions, we can define how they work. One could argue it doesn't matter the experience of a person or object because time units are just used to say when something has occurred or when it will occur. And human experience does not affect that. So what do I think? Would the astronauts be 5 or 36 years older? Should we use reference time or relative time? Well, in my opinion, yes. I blanked. I think that both of these understandings of time are valid and they both have their use cases. If you're worried about confusion, you can just say which time you're using. So the astronauts, if they were launched off at 21, would be 26 in relative time by the time they got back, just as much as they are 57 in reference time. Without reference time, it would be way more complicated to try to schedule anything. But without relative time, you can't accurately reflect how old an object is. But don't be fooled. The astronauts aren't in multiple times at once. This is because time units are just constructs that our feeble little human minds use to try to even begin to even grasp at understanding the very concept, the very beginning of the flow of time. I hope you guys all enjoyed the video. I know it's really different from what I've done before, so please let me know what you thought in the comments below. If you guys liked it, I'm thinking of making more content kind of along the lines of this. It's probably not going to be as sciencey as this one is. I have a whole list of ideas, but most of my video ideas, well, they actually kind of flip-flop between being being like sciencey like this one, but there are also quite a few that are just for fun. So let me know what you think. I tried to keep this from being too boring, so if you have any suggestions or thought it was boring, please let me know. And if you like this style, but maybe you don't want all the sciencey stuff, let me know and say, hey, make some fun, make an actually entertaining version of this instead of trying to talk to me about the concepts of time while I'm on summer vacation. My brain is supposed to be turned off right now. Anyways, I hope you guys enjoyed, and see you in the next video. Unless I die before then. That would be bad. As I see it, there are 3 different ways to view time. That's not a 3. Nice passion, Atticus. I'm liking my delivery. I need some water. Water. That was pretty good. 2 more times though, because I like to have 3 options, because 3 is a magic number.